Very good morning, Monica. Today, we are going to see about the superposition theorem. Already, we've seen the superposition theorem. So, superposition theorem states that in any linear network containing two or more sources, the response in any element is equal to the algebraic sum of the response caused by the individual sources acting alone, while other sources are non-operative. So, what you need to do is in superposition theorem, first you need to take any one source, that is individual one source that is acting alone. There you need to find out the current, and after that again you need to find out the again you need to say, for example, if two sources are given, one source one time you need to take, another source another time you need to take, and after that you need to find out the particular current in that particular. Say, for example, this procedure for analyzing the network by using the superposition theorem. So first step is select any one source in the circuit. Only one source in the circuit you need to select. Next, step number two, procedure number two, set all the integer sources equal to zero. That is, replace all other voltage sources by short circuits, okay, and all other ideal current sources by the open circuit. So we need to set all the individual sources equal to zero, and we need to set the ideal voltage source by short circuit and all other ideal current sources for the by the open circuit, as you know before. Next, keep the dependent sources in the circuit undisturbed. Say, for example, dependent sources already we have seen. So this kind of dependent source, say for example, this bracket will come, timing bracket will come. So here voltage source, current source will come. So here what we need to do is we keep the dependent sources in the circuit undisturbed. Determine the direction, magnitude and direction of the current to the branch as a result of single source selected in step one. So, say for example, only one direction, magnitude and direction of the current to the branch should be selected in the only one direction. You should not select, say for example, this particular group in this direction, this this direction. Only one direction you need to select. Next, repeat the steps 1 to 4 for each source in turn until the component current through the desired branch current has to be calculated due to each and every source acting alone. Next point, add all the component currents to obtain the desired branch current. Algebraic addition is to develop for DC network. Okay, so all the component currents to obtain the desired branch current you need to calculate. Algebraic addition. After that, we need to make the algebraic addition. Say, for example, the current in the particular branch itself as you need to do the algebraic addition of two, say, for example, one source is acting one time, another source is acting one time. So, finally, you need to make the algebraic addition. Okay, so that is what's it. Next, that is for DC network. For AC network, phasor addition is being done. Phasor addition means, say, for example, for a AC network, angular also will be there. So for that, phasor addition is being performed. Say, for example, this is the circuit. It's having two voltage sources, V1 and V2. So here we are having three resistance. So the current to this particular point is nothing but I1 plus I2. So for example, this current plus this current, this current plus this current. So say for example, first what we need to do, first one voltage source you need to short circuit the voltage source V2, and you need to find out the currents. So next another voltage source you need to you need to calculate the two currents. So the current in this particular branch is this current plus this current. Okay, so when short circuit you found out, say for example, this current was there. So this current plus again by short circuit this thing, again this current you need to calculate. So that is the combination of the two currents. So that you need to calculate. So if the two sources are there, one source has to be acted at a one time, and after that you need to find out the current in two branches, and again next you need to short circuit another one voltage source. Again you need to calculate two currents, and This current is nothing but resultant current. Okay, this particular current in this while short circuit, this is I1. So while short circuit, this is I2. So the current is the algebraic sum. That is I1 plus I2 is the current is flowing in this particular that you need to find. Next, note the concept of superposition is very powerful only for linear networks and also for the linear system. So it is not for non-linear one, only for linear networks. So next, the superposition theorem applies to the independent sources. Okay, not for dependent source. Say, for example, a dependent source in the circuit is treated as a just another circuit element for the calculation purpose. The dependent sources are just like that. You take that dependent source. You should not do short circuit or open circuit. Like you should not disturb any whatever is there. The value that you take and if I do the calculation. That is what they say to note. Thank you.